Hello everyone, I'm Krzysztof Gogol. I am currently finishing PhD studies in computer science at the University of Zurich. I specialize here in L2s and decentralized finance. And actually, what's the difference between L2 and a rollup? It's a question that I once got at the university when I was giving a lecture to students about blockchains. I was positively surprised with that. Most of the people in blockchain conferences, also in this conference, they use those two words interchangeably. Their meaning is very similar, but not exactly the same, as you are going to learn very soon. But let's start with the analogy. So imagine a road system. That is connecting, your work, your home, university, bakery. You can easily get from one point to the other with a car and a local road. However, when you want to go farther, for example, you want to travel from Zurich to Munich, you will not take the local road. You will take a highway because it's simply much faster. And layer 2s are such highways. They are autobahns that are simply built on top of the large blockchains so that we can execute some processes in a more efficient way. And it's becoming an issue because blockchain and cryptocurrencies are gaining popularity. For example, in Switzerland, where I am now based, you can already pay taxes with Bitcoin. In some countries, for example, in El Salvador, Bitcoin is a legal tender. It means that when you go to a shop or a restaurant, they need to accept your payment in a Bitcoin. But there are some issues with the Bitcoin blockchain network. For example, a block time is produced every 10 minutes. So, it can be that, for example, you go to a shop, you pay with a Bitcoin, and you need to wait 10 minutes. To get a confirmation that the payment was successful. That's an absolutely horrible user experience. And what actually people in El Salvador and other countries are using for those day-to-day payments in Bitcoin, they are using layer 2. For that layer 2 is called Lightning Network. It's built on top of the Bitcoin network, and it's simply used for a very fast payments. Those payments, they are happening outside of the blockchain network, of the Bitcoin blockchain network, but later the results of the transaction, of the payment, is stored back within the original Bitcoin blockchain. We also need layer 2s on Ethereum. For example, one of the metrics that is describing blockchain is TPS. It's a transaction per second. And Ethereum today can process around 15 or sometimes 12 TPS. In comparison, credit card system like Visa, they are processing 65,000 transactions over a second. So we can't lead to congestions on the Ethereum network. And such congestions, actually, they were happening in the past. Maybe you heard about NFTs, you heard about metaverse. There was an event in May 2022 when API Club was launching a sale of a land in metaverse. And that land, there was such a big demand to buy that land in the metaverse that the Ethereum network got congested. And to execute any transaction in Ethereum, you needed to pay over $400. So that's also not good when, for example, you go to a pizzeria, you want to pay for a pizza, 20, 30 euros, but you need to pay $400 or $500 gas fees. So that will simply not work. And the reasons why Bitcoin and Ethereum and another blockchains have those challenges is because it's difficult to design a blockchain that is optimizing three components. That is optimizing decentralization, security, and scalability. Like Vitalik Buterin described it as a blockchain trilemma. And simply, every blockchain needs to choose only 2 factors from those 3. And simply, Bitcoin and Ethereum decided to sacrifice scalability for the sake of decentralization and security. And you can also think about that trilemma like the situation when you are renovating your house. You would like everything to be done very fast, very cheap, and also with a high quality. And typically, it's not possible to have all those 3 things. You need to sacrifice one of them. And this is what that blockchain trilemma with the security, scalability, and decentralization is about. However, there are different blockchains that are trying to solve that scalability trilemma. They are working on new consensus mechanisms. Like for example, Bitcoin is working on the proof of work, Ethereum of proof of stake. Now we have new DAG-based blockchains. Solana is about to launch a new consensus mechanisms. And you can think that layer 1 blockchain scaling, when you build a totally new blockchain, it's like building a new transportation system. So when you, for example, imagine that Ethereum is that road network, then Solana would be like traveling by plane, or Aptos would be like traveling by boat. It's like totally independent system from each other. So there were different types of the blockchains. Like the first generation of the blockchains was Bitcoin. It was a copy or fork many times. Those chains, I mean, they might be used for the payments as a store of value. But the interesting things actually are coming with the second generation of blockchains. And here Ethereum was the first blockchain that introduced a virtual machine. It was quite a big breakthrough, because with that virtual machine on the blockchain, it became possible to execute smart contracts. Smart contracts are computer programs that are hosted and running on the blockchain. And that simply gave the beginning of the whole series of the programmable blockchains. And after Ethereum came a lot of other layer 1 blockchains, so-called Ethereum killers, like Solana, Cardano, Near, Aptos. Aptos actually describe themselves like a Solana killer. And recently, DAGs are gaining popularity. It's when you simply construct a graph and try to propagate information in a blockchain using that graph.
What
Yes?
Solana killer?
I mean, this is how they position themselves earlier. Because right now, when we look at actually which blockchains are having, those programmable blockchains are having most of the users, it's number 1 is the Ethereum, an Ethereum ecosystem, and number 2 is definitely Solana. And Solana, let's say it's a fast blockchain, it's good for the gaming use cases, NFTs, and simply Aptos, having a similar vision, wanted to compete more with Solana than with Ethereum. So generally, layer 1 scaling is super interesting in itself. Our topic is layer 2 blockchain scaling. But maybe before we got to that, there is one more thing I want to show you. It's about security. Because everyone is working on that new consensus mechanism. Most of those blockchains, they work on the proof of stake consensus mechanism. And it simply means that instead of using energy, like Bitcoin, which is bad for the environment, we are using a game theory. And then those blockchains like Aptos, Solana, Cardano, they are all inventing new variations of the proof of stake blockchain. Meaning that, for example, to hack my system, you need to control 66 or maybe 67 or 69% of all of the tokens that are being staked. But there is a problem. Because when there is actually not, okay, it doesn't work anymore. There's a problem because when there's actually not too many tokens staked, or the value of the token that people are staking is very low, then it's still quite easy to attack the blockchain. And layer 2 blockchains, they are simply trying to inherit the security from the underlying layer 1 chain. Meaning that, for example, if you want to attack layer 2 on Ethereum, you need to be capable to compromise Ethereum consensus. To attack layer 2 on the Bitcoin, you need to compromise security of Ethereum. They don't have their own tokens. Maybe they don't have own tokens for the purpose of consensus and security. They rely on the underlying chain. And this is making those use cases very important, especially for decentralized finance. So maybe to sum up, yeah, layer 1 blockchain scaling is it's like building a totally new blockchain with a new consensus mechanism. Layer 2 blockchain scaling is like taking complex, not efficient calculations outside of my blockchain, doing them outside, but then storing back the results and the outcome back to that layer 1 chain. And there are different approaches to the layer 2 blockchain scaling. The first one is that Lightning Network on Bitcoin that I mentioned to you. It's simply used for the fast payments on the blockchains, so that we don't have to wait those 10 minutes of block time on Bitcoin. Another solution is a plasma chain. It's used by Polygon. And it works that way that Polygon is having their own blockchain, there's proof of stake blockchain, they have their own token. However, the valuation of the token is not too high. So what Polygon decided to do is once per day, we simply store all of the current state of our chain inside Ethereum. This is simply called a plasma chain, meaning that if by any chance somebody would manage to compromise security of Polygon, all of the history will be recovered from the Ethereum. And those snapshots are happening there once per day. And then rollups are going one step further than plasma chains. Rollups work that way that they don't store any data locally, but they use different cryptographic methods to state the whole history of their blockchain inside Ethereum. So unlike Polygon and plasma chains, there is no consensus, there are no independent validators, but we do everything like in a Go and store back results and the state inside Ethereum. And simply in the second part of my talk, we look into more details, how those rollups operate and manage to achieve that. So rollups work like a blockchain. So they are producing blocks. Inside those blocks, there are transactions. Those blocks are being put together inside bigger batches. And then those batches are being stored inside Ethereum network. And simply a server that is doing that aggregation, that bundling, is called a sequencer. Sequencer is a core component of every rollup. This is, just a server that is running somewhere in Amazon or Google Cloud, and doing that aggregation. And then currently there are over 130 rollups on Ethereum. And the largest one, as you can see here, is Arbitrum Base. They have like 15 billions of assets stored on those chains, which is quite often far more than another layer 1 chains. Also, when we look at the number of transactions, it's actually, there are more transactions happening on rollups on Ethereum than on the Ethereum itself. And the reason is, rollups are lowering significantly gas fees of Ethereum. And currently, gas fees on rollups are 100 times cheaper than on the Ethereum. You can see it here when on Ethereum, okay, it's from yesterday. We pay around $1, but it's very low. Typically, it's like $5. Sometimes it can even be 50 rollups. Whereas on, it's $1. Typically, it's around $5. And on the rollups, it's something like 1 or 2 cents to execute a transaction. So the difference is huge. But it's not only about the lower gas fees, but it's also about how many transactions we can process per second. I was showing you at the beginning example of those NFTs and the spike when there was a sale of land in metaverse. And simply, Ethereum is capable to process only 15 transactions per second. Okay, here it's showing 21, so maybe they improved something. But you can see how many transactions per second can be processed by, it's here in this column, can be processed by some rollups. For example, Base, Worldchain, Arbitrum, it's far more. On Base is 122. And it's important, it's not showing, that column is not showing the maximum available value, but simply the current value. So that's also a screenshot from yesterday. So yesterday, Base was processing on average 122 transactions per second. Another interesting metric is also gas per second, because some transactions are simpler. For example, when I send ETH to someone else, it's a rather simple transaction that's not using too much gas. But when I use a Uniswap and I try to exchange maybe my ETH into Uni token, this is more complex, it's using more gas. It is also, especially today, when we compare blockchains, rollups, yeah, we use this metric. How much gas per second can a blockchain process? And those differences in blockchain architecture, they are coming mostly from the proof systems that the blockchains operate. There are two approaches. One is the optimistic rollup, and the other is zero-knowledge-based rollups. Simply, optimistic rollups assume that we can trust everyone. That generally people, don't cheat and they are good. And what they do, they simply bundle those transactions from L2 and they put them inside Ethereum. And then there is a window of 7 days when somebody can challenge those transactions that are being stored into Ethereum. And if somebody finds that someone was cheating, then he is receiving a reward from that. And the system is working quite well, as long as everything is running on a centralized sequencer. Then with the zero-knowledge rollups, we take a very different approach. So before we store any transaction inside Ethereum, we always validate if that transaction is correct. And for that, we are using those zero-knowledge proofs. So I mean, that mechanism sounds much better. So you might think why all of the rollups are not using that zero-knowledge technology. And the reason is that this technology, like everything in IT, it's coming with some trade-offs. Maybe starting from a zero-knowledge, generation of those zero-knowledge proofs is expensive. That, I mean, the previous talk was about that. It's expensive and it also takes time, meaning that it takes, it's very fast, but it still today takes a few hours. And we need to wait for that. Also, it's more difficult to build a rollup that is supporting Solidity, programming language of Ethereum virtual machine using zero-knowledge. And simply for that reason, most of the, let's say, maybe not most, but early rollups simply started as optimistic rollups. Because, okay, yes, we have that 7-day window to challenge, but we have a full compatibility with the Ethereum virtual machine. We are very efficient. We don't need to pay a lot of money for generation zero-knowledge proofs. But now, as this technology zero-knowledge technology is improving, simply zero-knowledge rollups are gaining more popularity, and the optimistic rollups are working towards a transition into this direction of becoming zero-knowledge based as well. There is here actually one interesting thing, that a 7-day window, because you might wonder who is going to use a blockchain where we need to wait 7 days to confirm that the transaction was executed. And the reality is that we don't have to wait 7 days. We just wait 200 milliseconds. And then we know that transaction is confirmed. When we look at the blockchains, there is a term called finality. It simply means that it's a time that needs to pass when the transaction is becoming irreversible from the blockchain. And when it comes to Ethereum, Bitcoin, there's just one finality. But when it comes to rollups and layer 2s, there are two types of the finality, soft and hard finality. Soft finality means that the transaction can be removed from the layer 2. And the hard finality means that the transaction, the L2 transaction, can be removed from L2 and can be removed from the Ethereum. So it's much stronger. In the case of those optimistic rollups, that hard finality lasts 7 days. ZK rollups hard finality lasts a few hours. But if the users are trusting sequencers, which is the case today, then simply they assume that we can trust the soft finality, which is super fast. It's in seconds or in milliseconds. And this is actually one of the biggest advantage of rollups. So the first one is lower gas fees, 100 times lower. But the second is rollups are much faster. So Ethereum is producing blocks today every 12 seconds. But rollups produce blocks every 200 milliseconds, like the fastest one. And most of them produce it around 1 or 2 seconds. And there's also another innovation. This is what Circuit is doing. Because sequencers, before they bundle transactions and send to Ethereum, they can optimize some things. And like in case of Circle, you can, for example, put their AI agent that is monitoring for potential hacks. And if such hack is happening, it can be simply stopped and prevented. You can also implement some mechanisms that prevent MAV attacks, or they reduce it. This is what Unichain, this L2 of Uniswap, is trying to achieve. However, rollups are coming also with some challenges. I mentioned that we are having today over 130 rollups, which is simply difficult to use, to manage, if you are a user. I mean, I personally use, I think, like 10 or 15 rollups and have here some tokens on different rollups. You can use, maybe one wallet, but it's still cumbersome to manage it. It's even more challenging when you are a developer and you have application. Then you need to have application running on, 15 rollups and Ethereum at the same time. That's not the easiest way. And also, this actually what will be the topic of the next talk in this room by my colleague. It's about that sequencer that is today centralized, and it's simply acting as a central point of failure. And there are some works about what we can do about that, how we can decentralize it without breaking too many things that actually already work. Maybe the future of rollups is that you can build a rollup on top of a rollup and more rollups on top of them. It's like a fractal scaling. So we can have layer 2, layer 3, layer 4, and so on. And each rollup that we build on top of it is actually becoming faster, more efficient, but it's also coming with more security issues. And then maybe last example is Deutsche Bank, because Deutsche Bank launched their own custom rollup where they are experimenting with the tokenized real-world assets. It's a permissioned zero knowledge-based rollup that they are using. So there are different types of the rollups. It can be general purpose like Base or Circuit, but you can also have your own as custom rollup, only for your use cases. So to sum up, not every L2 is a rollup. Rollups are great for scaling. They are cheap, secure, fast, but they come with those trade-offs. And the major one is centralized sequencer. And then, thank you.